Hello, and welcome to Learning Check 8.03. So go ahead and try those questions, see how many you can fill in, then come back and correct your work, and then hit pause again and see if you can finish up to make sure that you got all those points on here. Okay, so how many activated complexes? Activated complexes are counted by how many humps that you see. We have the reactants are on the left and the products are on the right because the reaction is going from left to right. How do we find activation energy? Activation energy is the distance from the reactants to the top of the hump. So you would just take the difference of those two numbers to get your activation energy. When you're reading the energy of the reactants, you're just taking that line directly over. Same with the products. And now what if it's the reverse reaction? Reverse reaction means everything is backwards. So reactants are now on our right and products are on the left because now our reaction is going in reverse or backwards. And again, same thing you've been doing. You just go ahead over and read the number right off. Notice there's no numbers on the x-axis on the bottom. That is okay, because this is just trying to measure energy, which is in kilojoules. So don't forget your kilojoules when you write it down. Activation energy of the reverse reaction. You are going to do the same thing you did before, but now make sure you're going from the reactants on the right to the hump to get that first activation energy. There is different rules when there's multiple steps, but in year one, you don't need to know that. And what is heat of reaction? Heat of reaction, H of Rxn, or delta H of the reaction, and that is the difference between the products and the reactants. So where do I have that? Products and reactants. So notice the delta H absolute value is going to be the same whether it's in forward or in reverse. 35 minus 15 or 20 kilojoules. But you have to make sure you know your sign is correct. So this thing, the products, in the forward reaction, the products are greater than the reactants. Okay, that means heat exited. So it is exothermic. Exothermic is negative. So the forward reaction is negative 20 kilojoules. And then the reverse reaction, you just reverse the sign. So the reverse heat of reaction is 20 kilojoules. So that is part one. We're going to do part two now. Right. So in this one, go ahead and see how many questions that you can answer and then come back and take notes. So this guy has two steps because he has what? Two activated complexes, two humps. So step one is from the start until the bottom of the first hill. Step two is from the bottom of the first hill to the end. You can have four-step reactions. Typically, we tend to see 1, 2, and 3. But here, two humps, two steps. Okay, the first step here is the chemical reaction for the first step. And it says slow. So what do we know about the rate determining step? The thing that determines the speed of the reaction is the slow step. So step one is going to determine the speed of the reaction. Okay, but both steps are needed to get from your reactants to your products. So now we look at this equation to figure out what are the catalysts. They are in the reactant side and the product side, but not in the middle. So when I look at here, who is on the reactants of the first step and is on the products of the last step? That's what it means, reactants and products, but not in the middle, okay? Because step one, those are products, nitrogen monoxide and nitrogen trioxide, but then they had to keep going on. So what do we have that is in both of those? We have NO2 in both of those. So NO2, nitrogen dioxide, is going to be your catalyst. We put it in at the beginning, and then it got used up in step one. That's why you don't see it on the products of the first step, because it got used up as it was encouraging them to go faster. Remember, catalysts are those coaches. Okay, but then at the end, he reappeared because catalysts aren't actually a part of the reaction. They're just encouraging them to get up. So it has to reappear in that product at the end. What about intermediaries? Intermediaries are not a catalyst, okay, and they are canceled, so not in the overall reaction. So for this, we look at what is here on the left side. Okay. What reactants do I still have? I have NO2, NO3, and CO. What do I have on the right side? NO, NO3, and CO2. Okay. If you have something on the left and something on the right, it cancels. So what is able to cancel? Nitrogen trioxide. That means that guy appeared in the middle, but then was used up. So he's only in the middle part, either and the end of the first and the beginning of the second. He gets used up in the intermediary or the middle. So that would be your intermediary. And then how do we get the overall reaction? We see what's left. What's left on the left side? Nitrogen dioxide and carbon monoxide, because the left side is still your reactant and the right side is still your products. What's left on the right? NO and CO2. So now we just add those guys together for your overall reaction. Notice where I put the catalyst, because that is where he should be, because he's the coach of the reaction. And notice in this weird one, we do have some nitrogen dioxide acting as a reactant and some acting as a catalyst. That usually doesn't happen, but that's what this example was. I just wanted to make sure that you could see how to do those canceling. Now today, you're not going to tell me one thing you learned from this. You're going to tell me one thing that you would have liked to see on here for me to go over more. So not one thing you learned. Take down all the notes, maybe replay it again to see if you have it, and then tell me one thing that you wish would have been on 8.03 to help you see it better. And have a good day.